Some theorems about polynomials. In addition to division of polynomials, we will need a few theorems to help us find the solutions of polynomial equations. The factor theorem says that if we have a 0, x equals k of a function, then it will factor out perfectly, meaning the remainder will be 0 when we divide by it. Say we have f of x equals 2x cubed plus x squared minus 4x plus 1, and we're told that at least one of the numbers, -1, 1, 1/2, and -1/2 are a 0 of the function. We'll be able to tell which it is by determining which division gives me 0 as the remainder. It looks like x equals 1 is a 0 of f of x. A similar theorem is called the Remainder Theorem. It states that if we have a divisor of the form x minus k, we can evaluate the function at k, and that will be our remainder. We no longer have to divide in order to find the remainder. Using this theorem and the factor theorem combined, I see that x to the 5th minus 2x squared plus 1 has a 0 of x equals 1, because the remainder is 0. We'll also need to figure out what numbers to plug in to use the remainder theorem and factor theorem. For this, we'll use a third theorem called the rational zero theorem. If we have any rational zeros of the polynomial function, they'll be of the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. Let's see what our possible rational zeros are for f of x equals 3x cubed minus 5x plus 4. The factors of the constant term, so our possibilities for p, are plus or minus 1, plus or minus 2, or plus or minus 4. The factors of the leading coefficient, so our possibilities for q, are plus or minus 1 and plus or minus 3. We'll use these together and simplify as needed, so we don't have repeated factors to see that our possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. If I further wanted to see which of these are actually zeros, I'd plug them into the function and see what comes out as 0, rather a remainder of 0. You have now seen 3 theorems which are typically used together to find the rational zeros of polynomial functions. You can put this together with your division methods and quadratic formula or factoring to completely solve polynomial equations.